Hello everyone, my name is John and I'm a cybersecurity analyst. Welcome to this experiment that is titled DNS Query Inspection with Wireshark. Now, this is part of my experiment folder, which is a space for small scale tests and proof of concepts designed to validate tools and techniques in a controlled environment. So before we dive in deep, now let's quickly talk about DNS. So what is DNS? DNS is actually the short name for domain name system, all right? So in a simple term, we say DNS is like the phone book of the internet. So when you type a website name, let's say google.com, your computer does not understand that name directly. It needs the actual IP address of google.com. So something like 142.250.184.14 or anything, okay? So it needs that numbers to connect to the server. So now DNS as a protocol, it handles that translation behind the scene. This is what we don't see. This is what the computer does behind the scene. So DNS as a protocol converts that google.com to a machine IP address that is understood by the computer, right? So in a more sense, it's actually take the human-friendly domain name, all right, and resolve it into a machine-readable IP address. So this process happens every time you visit the internet, or maybe when you're browsing websites, you're sending an email, or even using any online services. So it's actually doing the DNS repeatedly, right? So in this experiment, I'll be using industrial tools like Wireshark. So what is Wireshark? So it's actually a powerful packet analysis tool that is designed to capture and inspect traffic or packets across the network. Okay. So what it does is that for this experiment, Wireshark will help us to capture and inspect how DNS queries and responses behave at the network level. Okay. So we will look at how the computer asks for domain resolutions and how the server responds. So that's just what we're looking for. How the computer asks for domain resolutions and how the server will respond. Okay. And what kind of data is exchanged in the process. All right. So to continue with this experiment, it will involve some few steps. Number one, step one, I'll be launching Wireshark. I'll be using Wireshark, so I'll launch my Wireshark. Step two, I'll filter the DNS query. Step three, then I will trigger the DNS query. Step four, I will inspect the packets. And step five, I will do what we call logging and observations, which is necessary for the purpose of this experiment. All right. Then, last but not the least, that will be conclusion and ending the whole experiment process. Okay. So, to start with this experiment process, I will start by opening our terminal. So we call this a terminal. So we start by opening the terminal. So now our terminal is open. Let's launch our Wireshark. So to do that, let's just enter the code or the command. Sorry, the command Wireshark. So for my password, computer is saying I should put a very strong password, and I've done that. So Wireshark is up and running. So Wireshark is up. Now step two. Okay, no, our Wireshark is up and running. So first thing first, we want to select our packets that we'll be inspecting. Yeah. So of this interface that is shown, we'll choose the one that is directly facing the external network, which is for me it is ETH1. So this one is actually facing the external network. Like this is where I normally browse through. So this one is facing the internet. So we'll be selecting and we'll be inspecting DNS traffic that is going through this this interface. So to continue, I'll click on this blue thing to start the capture. All right. So now let's filter for. You can see we're already getting packet that is coming to my system. So to filter packets, the next step is to filter packet for just our analysis purpose, which is DNS. So on the display filter, I will enter DNS and press enter. And all of those packets is gone because we're not working with those packets. Those are other protocols. We are working with the DNS protocol alone, which is the domain name system. Now, the next step on this experiment is to trigger the DNS query. So we have two ways to do that. We can either go to the Firefox and just open the browser and enter any website, maybe google.com, any website address, or we can actually use our command line. So which is I actually prefer. I'll use the command line. So let me move this to the side and put this to the side. Okay. So to enter our command, so we'll use our command line. So let me create a new terminal. That's a new terminal. So let's query a DNS. Right. So we'll be using a tool called NSLookup, right? NSLookup. So at google.com, right? And press enter. And that is it. So so what we just did was that we actually said we want to know more details about google.com. That's just this query. This query said that we want to get more insights, or what to get insight into google.com. So when we do that, and this is possibly our reply, that is the answer to google.com. So it's actually saying the name is google.com, the IP address is this. All right. the name is this, and the IPv6 address is this. So we can say the IPv4 address is this, the IPv6 address is this. So this is actually the query that we are looking for. But the reason why we are using a network tool like Wireshark is so that we can get more insight to what is happening in the network layer. All right. So now, time to inspect these packets. So first, now let's picture something. We have, when you open this, we have, you see this 2 is equally this 2, right? This 2. This first 2 is equally this first 2, right? So this is actually saying this is the name, google.com, and this is the query response we got from this query, google.com, and the response is on the class A and type A, right? Type A, which is an IPv4 address, and we have the name AAA. So let me quickly explain what this AAA means. This AAA is just a funny way. Let me use what funny way of saying that this IPv6 that we're saying that it has more, it has more address space than IPv4 address, 4 times the size. So we are saying we have size 1, 2, 3, 4. That is, it's just 4 times the size of IPv4 address that we can ever have. So it's just a common logical thing that they did here, but it's very cool. Yeah. So the response is this IPv6 address, and this is the IPv6 address. So let's quickly go into our inspection, right? So when we open the domain name system, we open the domain name system, the response. So we're working with just the response because that's what we're working with. So let's move this to the side. This is not what we're working with now. So under the domain name system response, we can see that we have the first thing called the transaction ID with a number. So what this actually does is this is just so you can see the transaction ID is actually a DNS packet actually that is actually crucial for matching queries to their corresponding responses. All right, so it's just like your ID for something that happened. That is just an event ID. Let me see what event ID. So that's it. So it's just it's responsible for matching queries to their corresponding responses. All right. So under the flag, which is we pay attention. This is what one of the places we pay attention to the response we got. Number 1 response we have is no error. So it says that the standard query response that we got from the query that we asked, that it returned no error. All right. So under the flag, we can see that we have the questions that we asked. So what were the questions that we asked? Question number 1 that was asked. We have one question that was asked, and we have one possible reply to our question. So when you go to the queries, then we can see the question that was asked. So the question was google.com type AAAA. So that means we're working with the IPv6 address system, right? And the class is an internet class. So when you go expand the answer we have google.com type AAA, which is IPv6, the class internet, and the address. This is the IPv6 address. All right. So we're actually saying that google.com is mapped to this IPv6 address. All right. Now let's do it for IPv4 address system. You can see for the IPv4 address, we returned no error still, possible 1 question and 1 reply, and the query was google.com. The question that we asked was give us an IP address that's matching for google.com. All right. So the answer came back. Google.com has the type A, which is IPv4 address system. Class is internet, and we have the IPv4 address system of 142.250.184.14. So that is basically what DNS resolution is all about: resolving domain names to the IP address that the computer can work with and can understand. So yeah, that's basically all for this experiment. Like I said, an experiment where we have short clip of cool videos like this. All right. So in conclusion, this experiment was a success because I've successfully captured the DNS traffic, triggered queries, inspected responses, and I will also logged my observations and meaningful insights. So my observations and meaningful insights will be logged, and I will attach it to this video. So the purpose of this experiment validates that Wireshark is actually an effective tool, for DNS analysis, and it gives me a deeper understanding of how DNS resolution works at the packet level. So thank you guys for watching. Thank you. I hope you learned 1 or 2 from my small 2 cents of knowledge, and I hope to see you tomorrow for a cool video. Every day like this, every day we do cool experimental videos on touching tools across the cybersecurity space. Thank you, and remain blessed.